Well, it's our last test before final exam, guys. So since we aren't in class and you don't get a chance to ask questions on the problems, I decided to make videos again for you. So if there's any questions, anything you don't understand, be sure and email me and let me know before the test on Thursday. So let's go ahead and start. So this first one asks us for the square root property. And if you remember on the square root property, we have to isolate the squared value first. So that means step number 1 is going to be subtract 3 from both sides, because we need to get that squared quantity all by itself in order to do the square root property. So then we have x minus 7 squared, quantity squared, I should say, equals 16. And then we learned on the very first page of 7.1, once we get the squared quantity isolated, we need to square root both sides. But then we learned a very important thing that's going to affect 8 different problems on your test. Anytime you square root both sides of an equation, you have to add a plus or minus. That's where you get your 2 solutions. Remember how we learned that 2 guarantees us 2 solutions? So then we get x minus 7, because this and this undo each other. They're opposites, equals plus or minus 4. And then we learned on the very first page of our notes in this chapter to write your 2 scenarios. X minus 7 equals 4, or x minus 7 equals negative 4. Add 7 to both sides. We get x equals 11, or x equals 3. So our 2 solutions are 3 and 11. And all multiple solutions are supposed to be in solution sets, so make sure you do that. So the next method we learned was called completing the square. That's where we have to add blanks to each side. So on completing the square, and this is why it's so important to do this practice test more than once, because if you do it once, you're writing stuff down, you're looking it up, you're copying from the videos, but the next time you need to do it without notes, without anything, just to make sure you got a good grip of it. Because there's a lot of different techniques here. We have square root property, we have completing the square, we have quadratic formula, we have factoring, which you should be able to do with your eyes closed, hopefully. But just lots of new stuff. So I would definitely recommend trying to do it again the night before the test, all by yourself, no notes. Okay, for completing the square, the first step was to take the constant over to the right. So very different than this. Well, I guess these are kind of the same. We did move the constant to the right. We did move the constant to the right. So in order to move anything across the equal sign, you always have to make sure and do the opposite. So then we wrote plus blank equals negative 44 plus blank. And this should be pretty fresh in your memory because we did this also with parabolas towards the end of the chapter. So then we had another formula we used where we did half of b squared, and that's how we made this into a perfect square trinomial. But whatever we add to the left, we also have to add to the right. So this is half of negative 14 quantity squared, which would be negative 7 squared, which is 49. So half of 14 is, or half of negative 14 is negative 7 squared, positive 49. And it's always positive, FYI. That's why I always had the plus, because anytime you square a number, it should be positive. Then we learned how to factor. Factors of 49 that add to 14 are 7 and 7. This says the signs are the same, both negative. So it's x minus 7 squared, because it would have been x minus 7, x minus 7. And this side is 5. And remember, we also had a little shortcut to get to this step. That was square root this, use this sign, square root that. So I did a little of both. I factored it. Factors of 49 that add to 14 are 7 and 7. But you should also be able to get there from this way. Square root of x squared x, you always bring that sign down, square root of 49, and then you square it, which we would have had from x minus 7 times x minus 7. It would have brought us here anyway. And then isn't this problem exactly the same as this? Like almost exactly the same, right? So we have a squared quantity equal number. And if you look back at your notes, you'll see completing the square. Last step, use the square root property. So I have my squared quantity isolated. So I square root both sides. And here's the second one you would miss if you forget this. Add plus or minus. Anytime you square root both sides, you add plus or minus. Square root 5 can't be simplified. These two undo each other. So we talked about these on the video for 7.1 also. These are not like terms. So here they were like terms, 7 and 4, they're just both regular numbers. But on this one, they're not. So I showed you in the video in 7.1 just to add 7 and just stick it right there. So that makes x equals positive 7, and don't forget to change the sign. If you cross the equal sign, you have to do the opposite, and it's plus or minus radical 5. So when I go to write my two solutions, the first one is 7 plus radical 5, which I can't add them together. They're not like terms. And the second solution will be 7 minus radical 5. So we did several like those first two in our 7.1 notes. But the most important thing on the test is to make sure you do the method they ask. Okay, the third thing we learned in chapter 7 was quadratic formula. So I think I'm going to write it up here so that x equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. And then that way we'll have plenty of room for our problem. Okay, so let's make sure this is focused. So to do this one, first off, in order to use a quadratic, we need to know a, b, and c. And in order to know a, b, and c, the equation has to be set equal to 0. So you can't say c is negative 9 because it's not supposed to be on the right side. Remember, a quadratic equation is ax squared plus bx plus c equals 0 or y or whatever. So until you have it in that form, you don't know what a, b, and c are. So with that said, your first step on this one before you do quadratic is to add 9 over. So x squared minus 4x plus 9 equals 0. So x squared minus 4x plus 9 equals 0. So now we can state our pieces. So a is 1, b is negative 4, and c is 9. So then we have x equals opposite of b. So if b is negative 4, the opposite would be positive 4. Remember, this is not read negative b, it's read opposite of b. So opposite of b, positive 4, plus or minus square root of b squared. So negative 4 times negative 4 is positive 16. And remember what I said on those first notes from chapter 7. Your first number under the radical should never be negative. It's a squared number, and all squared real numbers are positive. So b squared minus 4 times a times c all over 2 times a. Okay, so I'm going to move this up. So now the other big hint I gave you on this one is don't do this in your head. Do this part on the calculator, because 99.9% of the time, this is where students make mistakes. So let's go ahead and type that in. So remember, you don't type the radical in. You only type in what's underneath. So 16 minus 4 times 1 times 9, and that is negative 20. So x equals 4 plus or minus negative 20 all over 2. So then our last step is to simplify the radical before we write our two solutions. So there's two things you should be looking at right now. One is you should recognize that 20 can be broke down. And the second thing you should recognize is that a negative under a radical comes out as I under a square root. So let's go ahead and break negative 20 down over here. I have to put my paper clip back in. I'm kind of an anal freak and I can't stand it when my papers aren't lined up. Okay, so negative 20 square root. So like I said, the first thing you should do is bring that negative out as an I. And then 20 is 4 times 5, which is 2, 2, 5. And 2 2's come out as a single 2, so this would be 2i radical 5. So that's what we're going to put in place of negative 20. So 4 plus or minus 2i rad 5 over 2. So then the other thing we learned in 7.2 was if there's a GCF between all three terms, we can divide that GCF out. So there is a GCF of 2, so that means each one of these terms can be divided by 2. And that leaves it over 1, which I don't need to write. So my two solutions are going to be 2 plus I rad 5 So 4 divided by 2 is 2. I did the first one plus 2 divided by 2 is 1i rad 5. And the denominator is 1, so we can ignore it. And then the second solution is 2 minus I rad 5. So did a ton of those. I bet we did about 6 of those in 7.2 notes. So if you need a refresher, you can definitely find some in those notes. Okay, I think we have a minute left, but I think that's plenty of time for number 4. Well, not plenty. Okay, for factoring, we learned in chapter 4, it also must be set equal to 0. Just like the quadratic formula, you can't start without that. So we get 7x minus 30. So don't forget to do the opposite. You'll miss so many if you forget to do the opposite to bring it across. Factors of 30 that differ by 7 are 10 and 3. Signs different, largest plus, so x plus 10. X minus 3 equals 0. And if a times b equals 0, either a is 0 or b is 0. And that gives me my two solutions, -10 and +3.